We're going to be doing two things today. We're going to eventually get to a fun activity where we can apply some of this, but really quick review because it's been a while. We had a long weekend and a test and an assembly. We talked about in physics everything is a vector or a scalar. We said scalars have magnitude only. Vectors have both magnitude and direction. I said, Jackson, you're going to need to memorize which ones are which, but you just will because I'll keep repeating myself over and over. I'll keep repeating myself over and over. I'll keep repeating myself over. See, I did that. If you, the day before the test you're not sure, then you can panic and do flashcards and whatnot, but I wouldn't start doing that right away. We talked about the difference between distance and displacement. Displacement just asked how far you'd moved from where you started. It didn't care about your path in between. Distance asked how many steps did you take. And so we for example, looked at a bug on a number line. Its distance was 14 meters, but its displacement was -6. We decided just for convenience, we'll let left be negative, right be positive, up be positive, down be negative. You can write the words left, right, up, and down if you want to, but we're going to be lazy but organized. And then really what I introduced you to was the concept that speed was distance over time, or really that distance was speed times time. I think this was the version that I gave you on your formula sheet, I think on the second line near the right-hand side-ish or somewhere there, I think. Yes, I hope. We wrote down the shortcut for going from kilometers per hour to meters per second. You're going to be using that today. And then we did the echo, question. And I hope I said to you, I like this question. I like this question. I like this question. I did, yes? For example 8? Okay. I probably didn't add the echo, but I should have. So the shortcut for converting between kilometers per hour and meters per second, we said kilometers per hour to meters per second. Each of these was something to do with a 3.6. To go from kilometers per hour to meters per second, was it times by 3.6 or divide? It's on your formula sheet. You don't need to memorize it. What was it? Was it divide? So if you haven't put that on the bottom of the front page of your formula sheet, you really want to. And then to go from meters per second to kilometers per hour, it's not divide by 3.6, it's?
Times.
Okay. We're going to do a couple more examples, and then we're going to do an activity. Your homework is going to be every question on this sheet, but I'm really hoping I can give you time to work on it in class after the activity. Jeremy is driving at 18 meters per second. If he drives for 2.5 hours, how far will he travel in kilometers and in meters? Can anybody see why this question is instantly yucky? There's something I don't like about this question. You see it? Cody, what are the units here? What are the units here? Why is that yucky? I either want everything in seconds or I want everything in hours. Okay? So as soon as I see mismatched units, I already think I'm going to have to do some kind of a conversion. Cody, what's it asking me to find? Start with the word how. How far? Is that time? Everybody say no. Is that speed? No, you know what? It's asking me to find a distance. Okay, so I'm going to write part A. I'm going to write D equals question mark. I've written something down. I feel better. Cody, what do they want the units to be in part A? I could either convert this to seconds. Then if I find a distance, it'll be in meters, because I'll have meters per second and seconds. Or I could convert this to kilometers per hour. Hours. That'll give me an answer in kilometers. They're both about the same work. Do you want to convert this, Cody, to kilometers per hour first? Okay. So then I'm going to say this. T equals 2.5 hours. I'm not going to touch that. What is that 18 meters per second? Is that a distance? Everybody say no. Is that a time? What concept in physics is that? Starts with the letter S. Yeah, technically not a velocity because there's no direction, but if you said velocity, because it's, I'd live with it. Our abbrev for it is V with no vector sign. Because I'm doing a conversion and the units don't match, I'll write the units. If all of the units had been nice, then I'd be lazy and I wouldn't even bother putting them. Cody, I want to go to kilometers per hour from meters per second. It's something to do with a 3.6. It's either times or divide. I can't remember which. Should be on the front, on the bottom of your sheet. That's where we wrote it, right? Times? So on your calculators, let's all go 18 times 3.6. In your homework, Cody, I'm fine if you just do that. In our notes, let's write that we went times by 3.6. So when you're studying, you know what the heck we did. But I'm fine if you don't bother writing the times 3.6, if you just write equals and 64.8 kilometers per hour. Okay? I have a T, a V, and a D. Which equation? Well, the equation we're going to be using is this one. Can you see where that is on your formula sheet, Cody? I think it's the second line. It's technically average speed, and I got sloppy and lazy. Yep. What is the average speed in this question, Cody? Keep going. Look up. What's the average speed? I've listed it. Yes, and it's meant to be now. If you make your list, it should be fairly plug and chug obvious now. Yeah, 64.8. What's the time? And you'll notice if I put the units in, normally I don't, but I'll put the units in. I have hours on the bottom, hours on the top. They cancel. What are the only units left behind? What did I want my answer in according to part A? Woohoo! Right? Really? You jumped from that? That was nothing. What do you get? Now, by the way, I didn't type 64.8 times 2.5. I went answer button because I'm lazy times 2.5. Start using your answer button as a good shortcut. If you know it's the same number, use your answer button. You all have one. If you don't know where yours is, ask me later. Do you get 162 even? Yep. Units? Okay. Good. Ashton, what does B want me to find? 162 kilometers. How many meters? Anybody do it in their head? If you can, Ashton, then we'll just go straight to the answer. If not, you know what we're going to do first? Write down what they gave me. Right? So Ashton, write down 162 kilometers. I want kilometers to cancel, Ashton. Where's it going to go? Yep. And I want meters on the top. Kilo is 10 to the what?
3.
Where does the 10 to the 3 go? Where the kilo isn't. So on your calculator, Ashton, it's going to be 162 times 10 to the 3rd, which is what? And if I don't see the rest of you typing on your calculator, you can expect that I'll be calling on you shortly. So type. You know who you are. 162,000, Ashton? Yes? No? Yeah? Is that right? Mr. Dewitt, can I write that in scientific notation? You know what? It's about the same amount of writing whether you write 1.62 times 10 to the 5th or you just add the 3 zeros. So I'll just go with that. All right. An object can have a positive distance while having a displacement equaling 0. True or false? You know what we're going to do? We're going to vote. How high you hold your hand up is how certain you are of your answer. I'm positive. I'm pretty sure. I'm voting because Mr. Dewick will make fun of me if I don't vote, and Mr. Dewick will make fun of you if you don't vote. The one rule in my classroom is you have to make a hypothesis. So an object can have a positive distance while having a displacement equaling 0. Who says, Mr. Dewick, that's true. I think that's true. True. I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, I got 15. Who said, nah, you're full of it. It's false. 1, 2, 3. Was that a vote? No, okay, don't twitch. So 3. Convince me. Yes, what are you defending? True or false?
True.
Convince me.
You could start at, say, like on a number line, start at 0, walk to 4, walk back to 0, and you've moved, but you would...
So what would my distance be in your example, exactly as a number? What would and what would my displacement be?
0.
Okay, I love that. I'm going to be even more simple. I'm going to go 1 step forward, 1 step back. What would your distance be in total? Do the math in your head. Please, God, let them do 1 plus 1 without a calculator. Everybody?
2.
What would your displacement be?
0.
Okay. So, true. Doesn't always be the case, but all you need to do is find one exception, then it can be true. Okay. An object can have a positive distance while having a negative displacement. Ooh. Once again, we're going to vote. Once again, how high you hold your hand up is how sure you are of your answer. Okay. Who says, Mr. Dewick? I think that's true, Mr. Dewick. True. An object can have a positive distance while having a negative displacement. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh. We got a little controversy here. Who says false? Now, I will do these voting things all year long, and there will be some that are very tough, and every once in a while, that one person who goes off solo will have the glory of being right. Is Carson right this time? Convince me. Anyone? Yeah. Was that a, you did this, were you saying you, go ahead. True or false? What are you defending? What are you, true or false? What are you defending? Okay.
1 step forward, 2 steps back.
Or how about just, what's your distance? 2. What's your displacement? What's your displacement? -2. You know what, we could go really simple. We could have just said, you know what? 1 step back, for that matter. Your distance would still be 1, because distance is a scalar. It has no sign. It has no direction, much like your future. And displacement would be -1 to go backwards or left. Okay? Sorry. Okay. An object can have 0 distance while having a positive displacement. Ooh, we're going to vote. Once again, how high you hold your, we got to, it's democracy. You got to wait for election time. So here we go. An object can have 0 distance while having a positive displacement. Who says, that's true, Mr. Dewick, totally true. Is that a twitch? Is that a twitch? I got 1. See, it's funny because I see a bunch of kids do, so, or they'll try and turn it into like they were adjusting their hair or something like that. Okay, who says false? Who didn't vote? True or false? Okay, the one rule in my class is you have to vote. I'll call you on it. I'll call you on it. So we went with, oh, Nate, you got somebody else with you. And then lots minus, convince me. So I guess the onus is on those of you that voted true, give me an example of how that's possible. That you can have no distance equals 0, but a positive displacement. So if your distance is 0, how many steps have you taken exactly as a number? 0. If your displacement is positive, that means your position has changed, but you haven't taken any steps. Is that possible? Okay. Sorry. Yeah. If your distance is 0, it means you haven't moved at all, so you can't have changed your position. One of my favorite comics is called Foxtrot. The author, Bill Ammond, actually has a physics degree, and so every so often he'll stick some good stuff in here. It's looking at a family. The youngest boy, Jason, is the nerd boy. I identify with Jason, the nerd boy. We're almost done. Your timing is perfect in about 30 seconds. So Jason is playing football with his older brother, and it says this. Okay, here's the play. Go 40 yards downfield, then turn left and go 20 yards, then turn right and go 35 yards, then turn right and go 30 yards. Then turn right again and go 30 yards, then turn left and go 10 yards. Then turn left and go 15 yards, then turn left and go 20 yards, then turn left and go 50 yards, and I'll hit you with the ball. Peter thinks about things for a while, and he says, won't I be right back where I started? Jason says, I can't throw very far. So here's the question. What distance will Peter run in order to complete the play? Well, he would run 40 plus 20 plus 25 plus 30 plus 30 plus 10 plus 15 plus 20 plus 50, which is what? I can do this in my head, I'll bet you. Race, y'all. 20 plus 40 is 60, 85, 115, 145, 155, 165, 170, 190, 240? Double check me. 240? Units? Yards? That's why that's the abbrev for yards and not for years. That's why years is A for annually. If Peter ends up back where he starts from, what's his displacement? Cody, loud and proud. It's cold out there. I have taken the kids out on the field. We've run this play. The physics works. You do end up exactly where you started from. I'm not going to do that today because it's cold out there. So right now, your homework is every question. A few of you are going to have to leave, and then we're going to be also doing an activity. So let me hit